We conclude this lecture and this chapter appropriately with a review of the equations necessary for the calculation of the heat Q, the change in enthalpy delta RH, the work W, and the change in energy delta RU during chemical reactions. In view of the similarity between phase changes and chemical reaction, that is, constant T and P, we will proceed in the same manner as on the last slide of lecture 1.4 on phase transitions. First, we calculate the standard reaction enthalpy, delta RH standard, for 1 mole of reaction equation, using one of the 4 methods discussed in lectures 1.5 and 1.6, namely adiabatic bomb calorimetry, bond enthalpies, Hess's law, or preferably standard formation enthalpies. Then we calculate the number of moles of reaction equation for a given amount of reactant or for an expected amount of product. If n moles of reaction equations are involved in the actual process, then the reaction enthalpy, delta RH, is simply n times the standard reaction enthalpy, delta RH standard. Chemical reactions are carried out in the laboratory under conditions of constant pressure. The latter condition implies that the heat for the reaction, Q sub P, is equal to the change in enthalpy for the system. So we can write Q reaction equals delta RH. Note that in a very special case, when chemical reactions are carried out in an adiabatic bomb calorimeter, Q reaction would be equals to delta RU. The work W for a given amount of reactants and products is equal to n times the work for 1 mole of reaction equation, W standard. The work for 1 mole of reaction equation under standard condition is equal to minus P standard times V products minus V reactants. We demonstrated that the molar volume of gases is much larger, about 1,000 times or so, than the molar volume of liquids and solids. So when we calculate the volume of reactants and products, we neglect the volume occupied by liquids and solids, and only account for the volume of gases. So we can replace V reactants by V gas reactants, and do the same for V products. Since most problems in the life sciences consider conditions of pressures in the vicinity of the standard pressure, we can assume that gases obey the L-gas law and replace any volume by the number of moles times RT divided by P standard. So, in the end, the work for 1 mole of reaction equation is simply minus RT times delta Rn gas, the change in the number of moles of gas in the reaction equation. The work W is therefore equal to minus the number of moles of reaction equation times R times T times delta Rng. Note that we must use R equals 8.3145 to get the work in joules. Finally, to calculate delta RU, the change in energy of the system as a result of the reaction, we could write delta RU equals W plus QP. Alternatively, we can write delta RU as the number of moles of reaction equation times delta RU standard. Delta RU standard is actually expressed as delta RH standard minus delta RPV standard. Delta RPV standard can be written as RT delta Rn gas. You are now given a problem to practice what you learned in the preceding slide. We will work this problem in class, but you should feel free to get a head start following the hints that are given to you.